Hi, I'm Blue Hat, though a lot of you know me as CC567 or simply CC. And today I'm going to attempt to make my first scripting tutorial. Now, some of you may be wondering why I'm even making this due to the abundant amount of tutorials already available. Well, I'm doing it simply mainly because I want to. I've been asked by a lot of people for help on scripting or just, kind of pointers on to where to start scripting. I always get asked, how did you learn the script? How did you start? And, I'd want to show all these people, but it's not really practical to show like a lot of people how to program, personally one by one. So basically, this video is to kind of fulfill the role of me guiding people one by one, and just, I could just kind of point them to this video. So hopefully this video is useful to those who want to learn how to program. Now, in addition to that, you may be wondering why I don't simply point people to someone else's video rather than this one. Well, I feel like in a lot of tutorial videos, there are a lot of things that they kind of tell people to do, but they don't really explain them. They'll use syntax or shortcuts and just certain things that they teach people how to program. And they don't really explain why they're doing it. They just kind of make it up to be, oh, that's just a language. You do it because you're supposed to. And some people may be confused as to why they're typing certain things or why certain things are the way they are. So that's where my tutorial aims to be different. I want to basically show you why everything is the way it is. So hopefully this tutorial is useful, and I hope you enjoy it. Just for starters, I am going to assume that you have no programming knowledge. It's a beginner tutorial, so it just simply makes the most sense. But I will be assuming that you do have basic knowledge of Roblox Studio and how it works, how to use the interface, how to kind of move things around and whatever. So I am assuming that you have a little bit of knowledge, but in terms of programming, I'm not assuming you have any programming knowledge. So with that, let's get started. The first thing we're going to talk about is data types. Well, what is a data type? A data type is basically a kind of data that the program works with. And in Lua, there will be 4 main types of data. You have strings, you have booleans, numbers, and tables. So we'll start off with a string. A string is basically just a collection of characters, and this is declared by using quotation marks. You could see I have the variable myString assigned to the value hello, and that is of course a string. Note, I will be stressing the importance of that equal sign later in the video. It's really not an equal sign, it's actually an assignment operator. So there is no equality being evaluated here, it is assignment. So from this point on, you will hear me say assignment instead of equals. So the next variable we have is a Boolean. I've called it my bool and assigned it to true. And a Boolean value is basically just true or false. You'll hear a lot of programmers shorten that to bool, so they don't say Boolean, they just say bool. So we have my bool assigned to true. And in Lua, there are 2 Boolean values. You have true or false. So yeah, that's basically how that works. Usually these values are returned in relational operators. We will talk about that more when we talk about just operators in general. The next data type is numbers. In other programming language, I know Java, JavaScript, C, C#, whatever, Python, there are usually 2 or 3 different kinds of numbers. You have floats, which are like decimal numbers, integers, which are whole numbers, and like doubles, which are double precision and whatever, and long, which are like long precision. But in Lua, there aren't separate data types for numbers. All numbers are just they're just treated as numbers. So 5.4, 5, they're all just number. Floats and integers are not different in Lua in terms of data type. And the last data type that we'll be talking about, and perhaps the most important, are tables. Most programming languages have different data structures. So a table is a data structure. They hold data inside of a bundle so that it can be saved and used later. So there are many different types of data structures in other languages. Just off the top of my head, you've got arrays, which are ordered numbers or ordered elements inside of a list. You have dictionaries, which are key value pairs. We'll talk about arrays and dictionaries later, and tuples and all that stuff. But in Lua, that doesn't care about any of that. They just have one data structure called tables, and they're basically used for everything. So again, we will talk more about tables used as arrays and tables used as dictionaries. So don't worry. Next, we're going to talk about numeric operators, and these are important because they're really important for dealing with numbers and just kind of everyday operations with numbers. So these operators are very common, and you will see them everywhere, and we will use them a lot in this video. So these are all very self-explanatory. I won't spend too much time on these, but you kind of get the idea. So you have addition and subtraction. They basically give you the sum and difference between the numbers. So addition would be evaluated to 8, subtraction would be evaluated to 2, and I can go ahead and prove that right now. If I use Lua's built-in print function, or rather Luau's built-in print function, if I run the program, you can see it prints 8 down in the output window. So this value is being evaluated and then set to addition, and then I can just print addition. I could do the same thing for subtraction. This will give me 2, and so on and so forth. You kind of get the idea. So, yep, it's basic number operations, multiplication, division. I don't really need to explain those. Modulus I am going to explain because it's not too common. So the modulus operator basically returns the remainder of division between two numbers. So, for example, if you take 5 and divide it by 3, if you're not going into long division, you are basically going to say, oh, it's 1 remainder 3, remainder 2. That's, grade school stuff. So that remainder 2 is the modulus. So the modulus gets the remainder of division. I don't use it too often, but it does have its use cases. For example, if you wanted to test if a number was even or odd, you could check if that number is divisible by 2. And the way you would do that is simply checking if the modulus of the number divided by 2 is 0. So let me give you an example. Let's put in 11 modulo 2. And it gives us 1. 11 divided by 2 is 5 remainder 1. The remainder is 1, that is the modulus. So this number is even because the modulus is 1. I mean, a number is odd. But if you put an even number here, 10 modulo 2, 2 goes into 10 evenly, and there's no remainder. So the modulus is 0. So it does have its use cases. It has its other use cases. I'm not going to go over them. You will find your way once you start programming. Up next, we have table operators. So these are operators that are only to be used with Lua tables. And there's one, and this is the length operator. It is represented by a pound sign. So basically, you take a table like data structure, and you put the pound sign in front of it. And what it does is it gives you the length of the table. So if we go and print length, you will see it will print 5. Yep, it prints 5, and that is the length of this data structure. This is definitely used. Again, this is pretty useful. They're all useful. Subsequently, we have string operators. These are operators that only work with string data types. If you use this operator with any other data type, you will get an error, and that's the same for the above data types operators as well. So the concatenation operator is 2 dots in Lua. And what it does is it combines 2 strings. So it will take hello with a space at the end and YouTube. And if I print this, print concatenation, you will see hello YouTube. And it's pretty useful. I mainly use this for output. You could also use this with GUI stuff. It's pretty nice. So concatenation, very useful. The next big type of operators we have in Lua are relational operators, and these evaluate the relationship between 2 data types. So, for example, we have greater than first. It will evaluate true or false depending on the statement. So we have greater than is assigned to 5 is greater than 3. 5 is greater than 3 will evaluate to, you guessed it, true. And I will prove it to you by printing it into the output window below. If I print this value, you will see true on the output window. Oh, you see hello YouTube from our previous thing. Let me go ahead and remove that before it gets in the way. But you can see that greater than is a Boolean value, and in fact, the result of all of these operations are Booleans, and it makes sense. The answer to the question 5 greater than 3 is a yes or no question. Yes, no, on, off, true, false. Those are Boolean values. So the greater than operator can be used on 2 data types in Lua natively. That is the number data type and the string data type. So you can actually take 2 strings and compare them greater than or less than. By default, this is alphabetical. So if you print to the command line, print greater than string, you will see that apple is not greater than oranges because it comes alphabetically before oranges. So that is how Lua defaultly compares strings. And it's the same for less than. I don't really need to go over that too much, but you get the idea. Greater than equals to or equals to simply returns true or false, whether or not the first number is greater than or equal to the next number. So again, these are all Booleans. This is true, obviously. 5 is greater than or equal to 5. And if you also do this, 5 is not greater than 5, but it is equal to 5, so this will still be true. That is how the greater than or equals to operator works. Same for less than or equals to. 5 is not less than or equal to 3, so this will return false. Now we get to the interesting one. I mentioned this briefly earlier, that the equal sign we see used to assign variables values is not actually equals, it's assignment. This double equal sign here is in fact the equal sign that you know and love. What it does is it will evaluate 2 data types for equality, and this can actually work on any data type. So we can compare true to hello, and we can print equals to, and you will see this will evaluate to false, because guess what? True is not equal to hello, but if we put in 5 equals to 5, this will be true. Same thing if we do this. This will be, you guessed it, false, because that is a string number. There are some languages that will actually evaluate this as true, and we don't like to talk about them, so we're just going to pretend they don't exist. So, and finally, we have not equals to. This is the exact opposite of equals to. It checks for inequality. If you have programmed before, you may have seen it written like this, exclamation equals, but in Lua, it is tilde equals. So 5 is not equal to 3. This will evaluate true. And I will print it for you again. This will evaluate true. Cool. So these are relational operators. They're very straightforward, and you will be using them a lot just like the other ones. The last type of operators we'll be talking about are Boolean operators. So remember, Boolean values are true and false. So Boolean operators deal with true and false statements. And there are three types of Boolean operators. You have the AND operator, you have the OR operator, and you have the NOT operator. So we'll start with AND. The AND operator basically checks if both values are true. If both values are true, then it will evaluate true. Otherwise, it will always be false. So let me print bool AND. This will be true. True and true are indeed true. But if we do false, it will be false. If we do false and false, it will be false. If we do false and true, you guessed it, it's going to be false. So AND will always be false unless both statements are indeed true. And it makes sense. Like, if you wanted to say, if somebody asked you if you're ready to leave, and then they say, do you have your phone? Do you have your wallet? Well, then, if you don't have your phone, but you have your wallet, you're not ready. But if you have both that are true, you are ready to go. So it is true, you are ready. So it makes sense. The next Boolean operator is OR. OR will basically always evaluate true if at least one of the statements are true. So if we print bool OR, this will evaluate true. If we do true and true, it will also be true. And if you do false and false, there are no true statements, so it will be false. So in short, OR will always be true unless both are false. The last Boolean operator, but certainly not least, is the NOT operator. The NOT operator basically inverts the Boolean. It turns true into false and false into true. So if we print bool NOT, we will see false printed to the command line. Pretty cool. This is actually pretty useful because you can use it to negate not only these Boolean operators and an OR, but you can negate these as well. So you can make not greater than by simply doing this. Not, and then 5 greater than 3. What this will do is Lua will see not and say, okay, I'm expecting a Boolean. And remember, 5 greater than 3 returns true. So this will turn into true. And then this will be not true, and it will be false. So if we print bool not, you will see that it'll evaluate false. It inverts the result of greater than. So if we do not false, it will be true. Now you can also use this on Boolean operators too. So if we have bool AND, which is true and true, that will give us true. And we do not bool AND. Notice I am using the variable bool AND to substitute true and true because they are interchangeable. I could write it like this, but when you're programming, you don't want to write the same bit over and over again. We assign them to variables for a reason, so I'm going to use a variable. So not bool AND, which is true and true, this will give us true, but if we do not, it will return false. So we have effectively inverted the result of AND. This is called a not AND operator, or NAND. So if you've worked with circuitry, electrics, or even Minecraft, you are familiar with the term NAND. And it's the same thing for OR. You can invert the results of OR to make it so that it always returns false when one thing is true, and it'll only return false when both things are true. That is called a NOR gate, not gate, or a NOR operator. So if we print bool not, not true or false. True or false will be true, not true, false. So that is how Boolean operators work. You do use them. It may seem confusing when you see them as true and false, but when you assign variables to this, it'll make more sense, believe me. At this point, I'd like to go back to talking about data structures. Now remember, in Lua, there's only one data structure, and that is a table. However, that table can act as different types of data structures that are found in many other different languages. And the first one that a table can act as is an array. Now, what is an array? An array is an ordered collection of elements inside of a bundle. So we have the first element, that is A, the second element, that is B, and the third element, that is C. So if we wanted to print the first item in this array, you take the name of the array, my array, or even rather, you can just get the array itself. So you get the array itself, and then you tell it which item you want. So we want the first item, so you use brackets, and then the position of the item that you would like. So if we print this, let me make sure I don't have anything else printing. Okay, I don't. If you print this, oh, what's my error here? I don't think I have an error. Everything seems okay. I don't know what's up with that. Well, we'll just do it the easy way. We've already assigned it up here. So what we're going to do is we're going to get the array. Remember, this array is equal to this because they're variables, and we're just going to get the first item by using the brackets operator, and inside we put the position of the item that we would like. So my array 1, if we print this, you guessed it, it's going to print A to the output window. Pretty cool. So these are ordered. If you want to get the second item, you print 2, and 3 will give us C. Now, for those of you who have programmed before, you may be wondering, why isn't the first item 0? And that's because Lua has decided that arrays should be 1 indexed. That means the first item is not 0, but it is 1. In most other languages, the first item is 0, but in Lua, it is 1. You're just going to have to get used to it. It's really not something that can really mess you up. It's just kind of something you have to remember. So anyway, arrays are 1 indexed. The next data structure that tables can act like are dictionaries. What is a dictionary? A dictionary is a collection, just like an array, but they are not ordered. They have no order. You cannot reference an array by index like we did before. So you can't do that to a dictionary. Doesn't make sense. In fact, if we go and try it, we'll actually get oh, okay. Oh, right, because if we try and get the second item, we get nil. Because there is no order to it. It doesn't make sense. So what does that mean? Why can we use dictionaries? Well, dictionaries are for mapping key value pairs. So you have a key and you have a value. So for example, we have the key 1. Every key has to be surrounded in square brackets. That is just the Lua syntax. If you don't like it, I'm sorry. So we have the key 1 equals to 2. Isn't that a little, don't you find that a little strange? We have 1 equal to 2. And we have this string, hello darkness, and we're setting it equal to my old friend. And then we have the string is cool, and we're mapping it to a Boolean. Now, accessing each of these values is very similar to indexing an array. You put the name of the dictionary, use the brackets again, but inside you put the key you want. So let me actually change this to 3 to avoid confusion. So we're going to do 3. The key is 3, and we print 3, and it will give us 2. Because the key 3 is mapped to 2. If we give it the key hello darkness, it'll print my old friend. Same thing for is cool. If we give it the key called is cool, it will print true because the key is mapped equal to true. Defining a dictionary, defining the dictionary kind of helps you to understand what it's doing. You take a key, set it equal to a value, and of course separated by a comma for each element. Key equal value, comma. I should be saying assigned to value. Key assigned to value, comma. Key assigned to value, comma. And then this key is assigned to the value. And just as a heads up, tables can hold any data type, and dictionaries can map any key to any value. It doesn't matter if you mix data types like this. And maybe this is a little confusing, so I've prepared an example that'll hopefully clear that up. Maybe an easy way to kind of envision why you would use dictionaries. For starters, you can write this a lot more cleanly. Lua is really cool because it really doesn't care about spacing or indenting like other languages. For example, Python, they don't have any braces, so well, they do have braces, but indenting is really important. So if you indent incorrectly in Python, your code won't work. In Lua, it does not matter because everything has braces. For example, this data structure has braces, so you can actually define this on multiple lines. So I've gone and written the same data structure, but in a way that most programmers would write it. You have your key value, comma, but instead of writing it all in the same line, you can press enter and bring it down into the next line, and you can make it nice and clean. So maybe this will help a little bit. So again, we have the same dictionary, but written in an alternate fashion, and we can actually go ahead and print this. This does not affect the way the dictionary prints, but I'm going to print it so you can see what it looks like in the output window. So you see 1 that, 2 that, 3 that. Now note I have done some setting changes to my output window. By default, you may see this. Actually, you may only see this if you don't show expanded tables by default. You may see something like this. If you see this, don't panic. That is the default behavior to printing a data structure in Lua. All you're seeing here is simply the memory address in RAM where the table is stored. So if you actually had a way to view RAM addresses, if you went to this address in your RAM stick, you would see the numbers corresponding to the data structure in this position. So again, this is you can do that by going into your output window, get out of log mode, and you don't need to see the memory address. You just need to see expanded tables. And there you go. Now, let's go. Let me show you an actual example of a dictionary that may make a little more sense to you. So I've made this dictionary called student. And what I've done is I have all the keys as strings and all the values as either numbers or even another string. And let's add one more for fun. Let's call it present. And present being you are currently in the school. And we'll say true. Now note we still have every key value pair separated by commas. It's just that instead of writing it all in one line, kind of like this, or like this, I'm just kind of putting them on each their own line so it looks a little cleaner. So we have name equal to Jeff Goldblum, and we have the ID equal to some number. We have their grade as grade 7, detentions as 3, he's been very misbehaved, and present is true. Now remember, to access these, we can put in the name or the variable assigned to the dictionary. So we're going to put in student, and we're going to put in name. And this is going to print our Lord and Savior, Jeff Goldblum. And it's the same for the rest of these two. We can get his ID, and it'll give us his student ID. So that is, hopefully this kind of makes it a little more clear. Now, another thing that's nice about Lua is it has an abundance of what we call syntactic sugar. Syntactic sugar is essentially just a alternate way to write the same expression, but in a much prettier way. And I'll show you what I mean by prettier. Lua is really cool because, well, for starters, if your keys are strings, you don't need to write them as strings. You can simply write them right in the table like this. So we have name. So we can actually get rid of all of these. And this only works for strings. So if you want to assign a bunch of strings to values, you can do it like this. But note, you have to assign them. When you assign them, they have to be in quotation marks. And so let's go and do that. Now note, when you access them using this method, you actually still have to use them in string. This is simply just syntactic sugar, but you have to access it by string like this. Now, I don't know about you, but I think this is pretty inconsistent, where you have no quotation marks next to these strings, but you have quotation marks next to these strings. Well, Lua has an answer for you. There is another way to index dictionaries. So, and let me put this as a regular string so you can see. And you have to put brackets next to it. So there we go. So another way to access the values in a dictionary, you don't have to write it like this. If the key is a string, you can write it as a dot. So dot name. This is only true if your keys, that is the key mapped to a value, is a string. So if we do ID, print student ID, we get the ID. So let me put this back to how I had it. And again, this only works if your keys are strings. Let me repeat, this only works if your keys are strings. So if we do student dot grade 7, remember this is only if your strings are keys, and only with dictionaries. With arrays, this does not work. You cannot do this. .1, if it's an array like data table, you have to index it like this. So if your keys are, let me repeat, if your keys are strings, this is the only time you can reference an object, a key inside of a dictionary like this, student.grade. So I think I've spent more than enough time on the basics of Lua and the data types in Lua. So I think I'm going to end the video here. In the next video, we will be going into Roblox Studio and we will actually be referencing and manipulating objects inside the Roblox game. The reason why I'm not doing it in this video is because, one, this video is long enough already, but two, this is really important and deserves its own separate video. Every subsequent video will be referencing pretty much all of the concepts in this video. So if you do not understand the concepts in this video, the subsequent videos will be very difficult to understand. So please watch the video, and thank you for sticking around this long. If you have, let me know in the comments if you have any questions. I will be checking there from time to time. So I hope you enjoy, and thank you for watching.